All right, good morning. We're going to start with factoring. This is Unit 5, 5.1 in Algebra 2. Now, our first thing I want you to see is that the first thing you need to look for is a greatest common factor whenever you're factoring. And if the first term is negative, be sure you factor out a -1, so the first term would be positive. So let's work some examples. In this first problem, you see that your greatest common factor, you can divide both numbers by 3. So your greatest common factor is going to be a 3. And then they also both have an x. So 3x is going to be your greatest common factor. Now when you factor that out, what that means is you divide each of these terms by your greatest common factor. And then when you do that division, that is what goes inside parentheses. So 3x squared divided by 3x, the 3's cancel out to be 1. X squared is the same as x times x. Okay, so we have x times x over x. One of those cancels out to be 1. And so you're left with an x inside your parentheses. Plus 6 divided by 3 is going to be 2. And then these x's cancel out to be 1. So you just have x plus 2. Now if you wanted to check to make sure you did it correctly, you would just distribute. So 3x times x is 3x squared. So I'm going to write here, you would distribute. And again, that's a check. That's not something you have to do, but it's a way to see if you've gotten the right answer or not. So 3x times x is 3x squared, and then 3x times 2 is 6x. And that should be exactly the same as what your problem was when you started, and it is. So that means this answer is a correct answer. And that's factoring out a greatest common factor. Now we've got a few more examples, so let's go over a few more. Both of these numbers can be divided by 5. If you think about it, 25 is 5 times 5, and then the y cubed is y times y times y. And the 30 is 6 times 5 times y times y. Well, what do they all have in common? They both have a 5, and they both have a y, and they both have another y. So those things right there that they have in common, you would multiply together to be their greatest common factor. So the greatest common factor is 5y squared. Now what's left when you get rid of those things? Okay, if I divide by 5y squared, I'll put y times y. This 5 cancels out, these y's cancel, and when I say cancel, that means they've become 1, because anything over itself is 1. And what do we have left that wasn't canceled? We have 5 times y. Now, looking at this next one, when I divide by 5 times y, which is 5y squared, the 5, the y cancel, and so I'm left with a minus 6. And so that's the final answer when I factor out the greatest common factor from that problem. Okay, let's do the same thing down here for number 3. First of all, we see that we have to factor out a negative because we want this term to always be positive. So we have a -1 we're going to factor out. Let's do that first. That means that changes the sign of everything here. So we have positive 6x cubed plus 4x squared and then minus 8. Now let's look for a greatest common factor. Okay, so I'm going to leave the -1 here. And let's break this down into parts. 6 is 2 times 3 times x times x plus 4x squared is 2 times 2 times x minus 8 is 2 times 2 times 2. So what do they all have in common? Well, this first one has a 2, and that one has a 2, and the third one has a 2. But that's all they have in common, because these others, the second and third one, have 2's, but the first one has just a 3. So there's nothing, no more in terms of numbers that we can factor out. So that'll be a 2 that we're going to put in front. Now let's look at our x's. The first one has 3 x's here. The second one has 2 x's, but the third one doesn't have any. So I can't factor out a letter at all. So the only thing I can do is factor out a 2 from all of them. That's the only number or variable that they have, that they all have. That's what having something in common means you all have it. So I can factor out a 2. So what's left down here, and remember it was negative, so we had to put the negative in front. So now we've got 3x cubed plus that 2 cancels, and so we have 2x squared, and then this 2 cancels, so we have minus 4. And that's all we can factor out from that problem, that negative 2. Okay, look at number 4. This is the last one. They don't really have anything in common. 6 is 2 times 3, 15 is 3 times 5, and 11 is 11 times 1. And this has 2 x's, this has 1 x, and that doesn't have any x's. So there's nothing we can factor out in terms of numbers or variables, except we have to remember we want that to be positive. So we will factor out a negative 1, which means you'll have positive 6x squared minus 15x minus 11. And really we don't want to write extra things, so you would get rid of that 1 and just have a negative in front, because that in algebra and as you go higher in math, you don't want extra things in there. And so that negative 1 is just something that doesn't need to be there. All right, so let's look now. Go to our next page. And this teaches about a difference of squares. If there's 2 terms, that's important. 2 terms and 2 terms only. Okay? And a term is what's separated by a plus or minus sign. So this is a term and that's a term. This is a term and the y squared is a term. 25x squared is a term, 49y squared is a term. Okay, so all these examples have only 2 terms. Then you look for a difference of squares. Difference meaning subtraction. You have to have a subtraction sign. So look at these 6 problems, and we notice that this one has a plus. Number 9 has a plus. So that means it's not a difference of squares. So we can't factor it as a difference of squares because it's not a negative. And so there's nothing we can really do with that problem. It just stays x squared plus 9. Okay? That's your answer. You can't do anything with that one. It's not a difference of squares. So let's go back and look at the ones that are differences of squares. In order to be a difference of squares, there's another criteria it has to meet. You have to be able to take the square root of each of the first element and the second element. Well, the square root of x squared is equal to x, and the square root of 9 is equal to 3. So, in other words, then I'm going to have, when I factor it, I use this formula right here, the a plus ba minus b. So the square root of x is x, and x in the second one. The square root of the 9, I have a 3 and a 3. See, there's a and b in each of this formula. But the signs, if you notice, are different. So one sign is plus and one is minus. And that's something you just need to memorize. You need to look for it if you have two terms and see if it's a difference of squares, and remember that factorization. So let's look at this next one. Can you take this two terms, we have a minus sign in the middle, so we look, is it a difference of squares? The square root of 4x squared is 2x. The square root of y squared is y. And then the signs we know are one of each. And the reason it's one of each is if I multiply this back, if I FOILed it back, when you have one of each sign, your middle term adds to be 0. And let me just show you this 2 times 2, 2x times 2x is, 4x squared. Then when I multiply the outside terms, I have minus 2xy. The inside terms is plus 2xy. And I multiply the last, I get minus y squared. Well, you notice that these two are equal and opposite in sign, so they would add to be 0. And so I'm left then with my original problem, which is 4x squared minus y squared. Okay. Looking at number 7, the square root of 25x squared is 5x. The square root of 49y is 7y. And we have a plus and a minus. And so that would be your answer. All right, looking at 8. We have two terms. We have a minus sign. But if I can't take the square root of 5x squared, and I can't take the square root of 12 and get a nice even integer answer, I mean whole number integer, I would get a decimal or a fraction or something. So this, since I can't take the square root of it, I would just have to leave it just like this. And there's no greatest common factor. So my answer is just the 5x squared minus 12. I can't, it's prime. For right now, we're just going to call those prime if you can't factor them. Okay, now, if you learn your square roots from 1 to 20, squares and square roots, hopefully you would know that the square root of 169 is 13x. So we look, can we do is there two terms? Yes. Is there a minus sign between? Yes. Here's one term and here's two terms. Minus sign between. Can I take the square root of 169x squared? Yes. And I get 13x. Can I take the square root of the 100? Yes. I get 10. And so it's going to factor, the signs will be one of each in each of the factors. Okay. Now for our next piece, if there are three terms, okay, 1, 2, 3 terms. Again, the terms are separated by pluses or minuses. 1, 2, 3 terms. 1, 2, 3 terms. And the number in front is 1. Okay, so I had to pause the recording, and I'm not exactly sure where I was, but there you can see I've got 3 terms marked on these. If the number in front is a 1, so that means there's nothing in here in front of the x squared, it's just a 1 there, then we can often factor mentally. The process, even when you have a number there, is you multiply this first term, and if you remember back probably in Algebra 1 when you did the quadratic formula, the number in front of the x squared term is a, the number in front of the x term is b, and the number in front of the constant, or the constant term, is c. So a is 1, b is 15, and c is 3. Well, the process is you multiply a times c. Well, in the case of being 1, then it is just 36 here. And b is 15. So your job is to find two numbers that multiply to be 15, or 36, and add to be 15. Now they're going to add because one thing is if you look at this second sign, if it's positive, the signs in your factors are the same. Okay, and then I'm going to look at this next sign. So this is step 1, and then step 2 is they are both positive. And I know that because of the first sign in that group. So I'm going to put two sets of parentheses, put a positive in both factors. I know the only way to get x squared is if I have x times x. So I've got 2/3 of the problem done right there. Now I think of my two numbers. What are two numbers that multiply to be 36 here and add to be 15? Okay, so we have, think factors of 36. We have 9 times 4. Well, that would add to be 13. We have 36 times 1. That would add to be 37. We have 12 times 3. That adds to be 15. So those are our two numbers. So you put a 12 in one factor and a 3 in the other. And then that's your answer. And if you wanted to check it, you would FOIL this or double distribute and see if you end up with your original 1x squared plus 15x plus 36. So that's the method that you're going to use for these problems. So let's look at the next one, number 12. Same process. We have a times c is 1 times 14, so it's 14. B is -9. Okay, well this is an issue. Here, that positive says the signs are the same. But now we have a negative in this first spot here, so that says they're both negative. Okay, so we put our two factors. We have x and x, because that's how we get x squared, and minus and minus. Now we find our two numbers that multiply to be 14 and add to be 9, yes. Well, we have 14 and 1, that's not it. 7 times 2 is 14, 7 plus 2 is 9. So that's our two numbers, 2 and 7. And if you check, look at the last two numbers. -2 times -7 is positive 14. -2 plus -7 is -9. So we're where we want to be. Looking at number 13, a times c is -22, and b is positive 9. All right, now we have a negative sign there. So if the sign is negative, or factors, the signs in the factors are not the same. Okay, we have a positive and a negative. Now, if the first sign is positive, that means our larger absolute value number is positive. So we can make our two factors, x plus and x minus, because we know the signs are different. Now we're going to end up subtracting these two numbers to get the 9. Okay, so we think of our two numbers. We want to multiply to be -22. Well, we have 22 and 1. Subtracted, that's 21. We have 2 times 11. Okay, so we have 2 and we have 11. That will multiply to be 22. If we make the 11 positive and the 2 negative, because we know we have to have one of each sign, when we add those together, we get a positive 9. So that means that the positive factor will be 11, and the negative will be 2. Double check, look at the last two numbers in each factor. 11 times -2 is -22, and positive 11 minus 2 is positive 9. So that's a good solution. This is called factoring. Looking at the next step, same thing. Look at our second sign here. That tells me we have a plus and a minus. We know the first terms are x and x. Now we know that again because there's nothing in front of the x squared. There's a 1 there. It's understood it's there. Okay, two numbers that multiply to be negative 14. We have 14 and 1 and 2 and 7. Those are our two options. Which ones add to be negative 5? Well, if I have a negative 7 and a positive 2, that's going to multiply to be negative 14 and add to be negative 5. So then you put those numbers in your factors and you are finished. Alright, let's look now at the last set. Okay. And for these we have to factor out a greatest common factor. In this last section, we're factoring completely. And what that means is you might have to do two things. You may not. That's, you just don't know. But you've got to factor it all the way down to the lowest quadratic factor, which would be x squared plus something, or to all linear factors, which is just x or x plus, x minus something. So, first, greatest common factor, that's always the first thing. So looking at the first one here, the greatest common factor is a 3. So we're going to divide everything by 3. And remember, what do you do with that 3? Well, you write it in front of a set of parentheses. And then you do this division. That's going to leave you with x squared plus 8x plus 15. Now, this is not linear. We've got this squared term here. So we have to at least see if we can factor it anymore. So in your answer, you still have to continue with the 3. So bring that down to the next step. And then we need to see. Well, we know if we can get linear factors, we have an x and an x. And because the second sign is plus and the first sign is a plus, both of the signs and the factors are plus. So two numbers that multiply to be 15 and add to be 8. So a times c, remember, is 15 and b is equal to 8. So the two numbers would be 5 and 3. And so we have x plus 5 and x plus 3. Now if we go on to the next one, remember we don't want the first sign to be negative, so we know that our factor is going to have to be negative. And we're going to try negative 5 because everything ends in a 0 or 5, so we know we can factor out a negative 5 from everything. So negative 5 over negative 5, anything over itself is 1. Now, we also have, though, as I'm looking, we have an x cubed, an x squared, and an x. So we can also factor out an x. So we're going to factor out negative 5x. So we take one x out of these. We have 3 x's at the top, 1 at the bottom. 1 cancels out, so now we have x squared minus 10. 50 divided by 5. One of them's negative, is negative 10. X squared over x just leaves me with x. And plus, because those are both negative, 20 times 5 or 120 divided by 5 would be 5 will go into 12 2 times. So that would be 24, is that right? I think so. Okay, so now we want to see if we can factor the set of the parentheses. So let's think about what we have here. We're going to try to get it into two linear factors, which means we'd have x and we'd have x. First sign is plus, that means the signs are the same. We have a minus here, so that means that both the factors are minus. So now, two numbers that multiply to be 24 and add to be 10. Well, that would be 6 and 4. Now double check. Negative 6 times negative 4 is positive 24. Negative 6 plus negative 4 is negative 10. So that works out. So this would be the answer for that problem. Okay, going on to 17. Now we have two terms. So this is, we look at n minus sign, we look for a difference of squares. It's not a difference of squares, but there's a GCF, so we have to do that first. So let's factor out our 5. So if we divide 125 by 5, we have 5x squared. And 80 divided by 5 is 16. I'm sorry, that's 25x squared, not 5. Okay, so now we do have a difference of squares because the square root of 25x squared is 5x. And the square root of 16 is 4. So remember, when we have a difference of squares, we have two factors, and one is plus and one is minus. And so anytime you have two factors, you check to see if it's a difference of squares, or if after you factor out the greatest common factor, it's a difference of squares. At 18, okay, we have a negative 3 is our greatest common number. But what about the x's? Well, we have 3 of them on the first term and 2 of them in the second term. So they both have 2, okay, or at least 2. So we're going to factor out a 3x, negative 3x squared, because we want our first term to be positive. So you write your denominator, or what you factor out, in front. Negative 3 over negative 3 is 1. X cubed divided by x squared leaves us with 1x that we didn't use, or we didn't cancel out. Now, plus, because negative over negative is positive. 12 divided by 3 is 4. And the x squareds are identical, so that's 1. So we're left with x plus 4 in the parentheses as a factor. Now, what we have here, see, this is just an x. That's a linear factor. So we can't do anything else. And we can't factor this x squared down into more factors. So this is your final answer. Okay, well that's the end of this 5-1. And work on your homework, please.